Pleased to meet you all. We are here together today in a remarkable era. It's an era of technology innovation. We are living through that. And AI is a wave in that entire technology innovation space. And machine learning is a subset of AI. AI is a broader space. In today's talk, I may use AI and machine learning interchangeably. With that, let's review together where we are going to spend our next 30 minutes or so. A market trend in AI, like what is the general market pulse? Why, at what time something will be appropriate and not? Popular and common machine learning applications. And we'll take a specific look at conversation analytics, image recognition, diagnostics ML. We'll go over the use cases and techniques in these specific areas. Before we dive further, I'd like to introduce myself. By profession, I'm a senior product manager for industrial SaaS at Honeywell. And my background is product, startup strategy, and engineering. By education, I am engineering major followed by an MBA. And one of the fun facts about me, I did backcountry adventure in the Himalayas. Now we'll do a little quiz in this room. Please take a look at this slide. There are two truths and a lie. We'll try to detect the lie in this room. So please take your time to read a little bit, then we'll raise our hands. Okay, let's get started. Number one, how many of you think that number one is a lie? Please raise your hands. Okay, only a few, all right, it's fun. Number two, how many of you think that number two is a lie? Please raise your hands. Okay, we have some more skeptics on number two. Number three, how many of you think that number three is a lie? Okay, so you kind of evened it out inside the room. Let me reveal the lie detector. Number three is a lie. Actually, the country with the highest concentration of AI jobs is China, not Japan. Let's get started. What is behind the buzz? On this slide, I have Gartner Hype Cycle 2019. And there's a lot of information on this slide. The way to go about it is take a look at the colorful balls. White balls means those kind of AI technologies will be ready for mass adoption or will reach steady state mass adoption within next 2 years or so, less than 2 years. And the lighter blue bulbs on the slide, those kind of AI and ML technologies will reach steady state adoption between 2 and 5 years. Darker blue bulbs mean within 5 and 10 years. And you see 3 red dots on this slide. Those are the technologies: quantum computing, artificial general intelligence, and autonomous vehicles. Those will be ready after a decade, more than 10 years. Most of the AI, ML, and related technologies we are talking about will be ready for mass adoption between 1 and 10 years, except those 3 outliers, more complicated areas. Now, what is the list of common machine learning applications? I'm trying to put machine learning in a box within a 30 minutes time box session. And the list spans conversation analytics, image recognition, diagnostics machine learning, arbitrage ML, scheduling ML, and search machine learning. The top 3, highlighted in blue, we'll take a closer look today. For the bottom ones, we'll not have enough time. Very quickly, what I mean by each of these terms, at least the bottom ones. Arbitrage ML, that does arbitrage. What does that mean? Investment, financials, buy stock, trade stock, arbitrage required. Machine learning automates that. That is arbitrage ML. Scheduling machine learning. Think about Uber, Lyft, how your ride is being scheduled online right at that moment. And search machine learning. Of course, the first example is Google search. How it's collecting the data, scraping the web, doing search ranking, and finally serving you within moments what you want. With that, let's go and start with a conversation analytics. On the left of this slide are the problem areas, why conversation analytics became important, what kind of problem it aimed to solve. Any organization has this kind of question in mind. How do I keep my customers happy? How do I make my company's employees more productive? And I have done many things. How do I know how I'm doing? How do I gauge it? In response, the solutions comes like chatbot, productivity assistant, reputation monitoring. Here is an example of chatbot from utilities industry. An user is talking to utilities customer service. If you look at the first question, hi, I'm moving and need to change my address. What does it tell us? Number one, people move all the time, and utilities receive a lot of phone calls. Hey, please help me changing my address. You see, this is a very frequent task and repetitive, pretty mundane as such. And also, the first sentence is not starting with a question mark. That means a chatbot must be able to read interrogative and imperative sentences. And I would like to underscore a few points. Chatbot has become very experimental. Prior to 2016, there were chatbots. It's not very new, but it didn't see mass market adoption. Why? A, that time chatbots were very slow. User will go home before getting an answer. The point is moot. Number two, 75% of the time, human assistance was required, and chatbot couldn't handle the query. Again, the point was moot. Now, with technology advancement, those kind of barriers are overcome. And chatbots are very specific. They address very specific problems in specific domain. And in essence, what it needs to do, it needs to understand the context and mood. Mood means, is the customer angry, happy? How do I handle? Very sophisticated for a chatbot. And context, what is the ask? In this case, address. Okay, get it done, everyone is happy. 24/7, tireless chatbot is there to do the job. Next, productivity assistant, AKA digital assistants. Siri, Alexa, Google Home, all familiar consumer technologies. It's a leap forward from the chatbot example. In a sense, digital assistants needs to understand any generic query and needs to reply with generic answers. The domain is much broad. It's no longer a very specific, small, boundary thing. And the concept from consumer industry is applied to the industrial world too. In industrial world, think about mining worker, factory workers, who are very mobile in nature and who are not sitting in front of a computer. When they are doing their field jobs, they have complexities in their work. If they are stuck for some reason, if they can reach out to a digital assistant, hey, I'm trying to do this, but I don't know how to do it. Can you help me? Then that digital assistant could go and check hundreds of pages of instruction manual, find out what is required for this particular procedure, and guide that worker. That's a huge productivity boost in a commercial sense. Reputation monitoring. This is based on the Wild West. Think about web and information we have today. Social media information, news articles, people are talking over the internet, so there's lots of information. And sentiment analysis came to understand what is the meaning, what is the underlying theme within this kind of content. If you look at left of that slide, that's an event extracted sample from social media. As you see, key points are, there's a company, Apple, whose CEO, named Steve Jobs, is resigning because of cancer. From that event, what kind of insight can be drawn? That industry is thinking Apple is shaking at this moment. It's not a very positive move for Apple. On the right side, that's a snippet from a news article, and I have tried to highlight the main keywords there. Apple is giving 2020 Q1 guidance. And Apple is saying that we are going to have our strongest quarter ever with a record revenue this much amount. What does sentiment analysis, reputation monitoring understand out of this? Number one, it's a forward-looking statement. Number two, it's a very strong performance. That's how companies can gauge where they are. Now, this is a very brief primer about tools and techniques in text analytics. Natural language processing, normalization, parts of speech parser, semantic parser, these kind of things are required. And no machine learning model is successful without the data. What are the data in this case? I see in this display, you are not getting the right fit, but anyway. Social media data for scraping through the web, customer interaction data, internal company data, for those kind of chatbots which are very domain specific, going over frequently asked questions, a knowledge base. And I also want to give you a sense about the volume of data. In case of Facebook, there is about 300,000 status updates per minute. So think about sheer volume of data needs to be processed. And inside machine learning domain, what kind of problems these are? Primarily deep learning and unsupervised learning. Library and framework. Popular ones are PyTorch, TensorFlow, bot-specific SDKs, and natural language toolkit. And of course, you will choose depending on what exactly you want to accomplish, your objective evaluation criteria, and how far down the path you want to go to modify the algorithm, or you want to use something more out of the box. Beyond text, this is some interesting fact. More and more, text is becoming voice. In case of digital assistants, you have seen, no one is typing anything to Alexa. They're asking Alexa, Alexa, what is going on? Tell me this, tell me that. So a subtle interface is emerging. And while there are use cases for text analytics, those are also being replaced by voice, or more use cases are emerging for voice. And the same technology is adopted for language translation. Think about Google Translator. If you could do one thing in one language, you could adopt that to any global language. We have not reached the scale of any global language, but eventually we'll be there. Now we are into image recognition. Again, left side you have problem, right side you have solutions. What kind of problems are inspiring image recognition? Know the ask, and how does something make sense of its environments? And what are the application area solutions for that? Image search, facial recognition, robotics, autonomous vehicle, military surveillance, so on. We'll take a look at a couple of those. This one is a picture of a screenshot of Google Lens. So that's a smartphone app by Google. If you check your smartphone and point to an object, then Google will tell you detail about that object. In this case, there's a flower. If I point my phone, Google is telling me this is the species of the flower. I can click, I can get to know more. The same thing could be applied in ad space. If I point my camera to my app and camera of the phone to a shop, I will know about the shop's review, what kind of things are served in that shop, so on. On the right side, a much more complex scenario of image recognition, that is autonomous vehicle. In order for an autonomous vehicle to be trained, to be driven, it needs to understand the environment around it. It's not a single image, multiple images. Pedestrian, lane marking, the landscape, other cars, stop sign, road directions, the list will go on. I mean, thousands of things are there in that environment. The point being, we are seeing three things here. Number one, incremental innovation. Google had, for example, a text search. Then it had voice search. And now we are seeing a case of image search. Part of your technology is staying constant, and part of it you are augmenting. You are taking it to the next level. Another thing is complexity. Image recognition as such is a much more complex work. Depends on the quality of the image and how you decipher an image, all of this. And even within these two examples, actually you see a very broad spectrum of machine learning. Something more simpler, something absolutely more complex, more than 10 years ahead of time. And time criticality is of paramount importance in case of self-driving car. If a car is being trained to be driven by itself, it needs to see that object and it needs to know what is that object right then and there. After a few minutes, the point of autonomy is completely moot. And self-driving car is not only about image recognition, it will also hit much more complex areas of machine learning like reinforcement learning, agent-driven simulation, agent-driven training, all of those. Again, in short, tools and techniques in image recognition, normalization of image, dimension reduction, feature detection, so on. What kind of data will make image recognition possible? Of course, images from the domain sources, the company's data, and also satellite images. Think about Google Map. What kind of problem type? Deep learning, supervised learning for the image recognition part, and full self-driving car, again, reinforcement learning and different kind of libraries. Libraries and framework. One point to note, a particular image is made of pixels. That means it takes a lot more space to store an image. How you can find something that can compress the image without compromising the quality? So some kind of codec software you require for that. If you need to process the image, not only analyze the image, that means you will do some modification on the image. OpenCV kind of libraries, and Image AI, Google Vision kind of libraries for analyzing the image. You will have the APIs for image analysis. Now, few interesting facts. When we have new problems, new solutions, we need a new angle to solve those. Image recognition is a supervised kind of problem. That means a computer learns to recognize images by looking at images. In order for a computer to be trained, these are the dog images, the computer will see a lot of dog images and a bundle of non-dog images. And that's how it knows what it is, what a dog is, what a dog image is. That means we need labeling of images. Who is going to do the labeling? Amazon came up with crowdsourcing, a project called Mechanical Turk. That's a crowdsourcing marketplace. Companies can go and get crowdsourced, and those crowdsourced can do the labeling of images, and many other so-called tasks for machine learning. ReCAPTCHA image. When you do something, Google search or getting into a website, it will ask you, okay, I'm showing you these 12 different images. Please mark those images which have a bike. You mark it, Google got labeled image from you. On the right side, synthetic data. What is that? For self-driving car to be trained, it needs lot of different scenes, lot of different seasons. Like same street of Boston will be different in spring and will be different in the winter. At night, during the day, terrain will change, landscape will change. And that's so many variations. To generate this kind of data, companies are leaning towards video game companies. Video game has set up scenes. When the game is being played, the photographs can be taken and those images can be used to train self-driving cars for simulation. Now let's move to diagnostics, diagnosis ML. The problem, I think this is the simplest problem anyone can think of. How do I know if there is a problem? In response, the solutions we are seeing in the areas of efficiency, medical diagnosis, and industrial asset health. Efficiency. The picture is of commercial property. And commercial property owners want to know at least a year ahead what will be the energy cost and how to optimize the energy cost. What is the main culprit driving the cost? In absence of machine learning, the option is after things happen, something consume more energy, they will be able to know, okay, this is the culprit and will optimize. If machine learning model can be better than that reactionary approach, then we have a product market fit, a viable business case. Medical diagnosis. This is much more critical case because we are really talking about people's life. The statistics says that 10% of patients' death is due to error in diagnosis, and that's an alarming fact. How machine learning diagnostics can be helpful here? Train a computer with the data of healthy individual, biometrics data of healthy individual, with that of patient's data, and the model will learn. And diagnostics ML in healthcare is not only limited to textual time series kind of data, it could also lean to image recognition. For example, to detect blood cancer or skin cancer, teach a computer, this is malignant cell and this is non-malignant cell. It will run those images and come up with diagnosis of diseases. Industrial asset health. In absence of machine learning, what is the option for industrial companies? Industrial companies have fleet of machineries. The way Amazon has fleet of truck to deliver, industrial companies run on machineries. And it's important for them to keep the production line up. If they don't have machine learning, they will dispatch a technician with some time-bound schedule. Let's say first week of every month or first week of every quarter. And the risk with that is if some machines have already broken down, then the risk is materialized. The company's top line is affected, the company's bottom line is affected. In a sense, the company has to arrange fixing that machine, and there will be an opportunity cost to get labor and material at a very short notice. And the use cases are not only confined within the actual equipment assets, it also spans to manufactured product quality. If there is a defect in the manufactured product, do you want to continue with that defect and ship it to your suppliers, receivers? You don't want to do that. You want to diagnose it sooner, stop it right there, address it right there, and go from there. These are the areas where machine learning automates diagnosis and gives a notification to the companies, to the industrial companies, hey, something is going to fail on so and so day. And even better, if with the help of diagnostics and root cause analysis, it can address the problem. Tools and techniques in diagnostics. Usually an ideal model is configured, and domain expertise is required in all kinds of machine learning problems. This one is even more important. Use domain experts' help to build those models and do anomaly detection. current state versus that ideal state, how much deviation. Data, maintenance records for industrial companies, sensor data, third-party data, for example, weather data, if that has something to do on the machinery health, product health, and medical reports in case of medical diagnosis. What kind of problem type it is? Deep learning if image is involved, as we have seen, supervised, unsupervised, hybrid of supervised and unsupervised, a mix of those. Library and framework, there is no popular library or framework just for this purpose, diagnostics. Meaning that you are not having readily available API to do diagnostics on something. You have to go on your own, use the scikit-learn or whichever library you are choosing, and come up with the tools for your trade. I want to leave you with a few departing thoughts. With the technology changes around AI and machine learning, it's changing rapidly. Why and what you want to focus. Talking about the Gartner's hype cycle, that will help you to prioritize where do you want to spend money now versus later, how much time you have, and what is your appetite. Emerging use cases, you think about the text versus voice. Text analytics was there in some form. People were interacting with text. And voice was non-existent until a few years ago. So stay tuned with the market, with the trends in this technology. That's how your organization will cope up with what is going to become prolific. And cross-industry problem solving. For example, Google is using image search for its advertising business in certain ways, as we have seen in image recognition. And many more automobile companies are trying to achieve complete autonomy with self-driving vehicle. These are two different complexities. Achieving that full autonomy is very complex. But for your organization, the chances are you don't need to be that complex right now unless your industry is ready. So choose something in between, what is the lower hanging fruit, and go from there. And creative juice keeps flowing. I think all machine learning projects are very experimental in nature. You have to keep doing experimentation, right? For example, Chatbot. If it would have stopped in 2016, then we wouldn't see this kind of prolific uses of chatbots the way we are seeing across industries. Retail, finance, Bank of America's Erica, probably you all are seeing that. And point being, don't stop if you are seeing an obstacle. Look at your organizational risk appetite, ROI, innovation trend, and move from there. There will be moments of discourage, but don't let that stop you. And one idea, multiple applications. Chances are many times your central data science team will be able to build some generic pattern recognition algorithm. Then you try to circulate that algorithm across your multiple strategic business units. You are saving cost, you are able to get towards a more matured central data science team who is helping the entire organization, bringing ROI faster. I think that's all I have for you today. And there's the link. If you have any question later, you know where to find me. And I'm also available during the breaks. Thank you.